Okay, let's jump in. If you have a question, ask me. Ryan, go for it.
I had a question on the last test that we took. Problem number 7, which was with A.
Yes.
Can you go over how to do that one again?
Yes, I certainly can. I'm going to connect my iPad.
Thank you.
Feel like I have this question memorized now because it's commonly asked one. Okay. You guys can't see that yet, can you?
Not yet.
All right, let's try this again. Give me a second. I just tested this. Okay, let's try this. All right, I'm going to disconnect and try again. Oops. Okay, let me see. If you're just joining, I'm just trying to connect my iPad. Ah, yay, that works, right?
Yeah.
Okay, let me open up a screen. Okay, so here was the problem. It was, and just correct me if this wasn't it. I'm just doing it off memory. I think it said I gave you that inverse tan of 0.4 equals A. That was the given, and you had to solve in negative pi to pi, give me all solutions to tangent 2x equals negative zero point 0.4. Is that right?
Yeah, that's correct.
Okay, great. So first thing I do when I'm solving for on a given interval is since the x isn't singular, I'm going to set up the inequality because I know x has to be between negative pi and pi. So first, if the angle isn't singular, I'm going to treat it as if it is. So because it's 2x, I'm going to solve between negative 2 pi and 2 pi. And I have to solve that far out because when I eventually solve for x, it's going to bring things back between negative pi and pi. So that's the first thing I do. And when I think about what 2x is going to equal, I'm going to go back to my given information. Like inverse tangent of a positive ratio, what quadrant is that angle in?
Quadrant 1.
Yes, so this is a quadrant one angle, which even better, it's my reference angle. Any quadrant one angle's the reference angle, and I can use that to find any angle I want. So then thinking about when tangent is negative, that means I'm going to give quadrant two answers and quadrant four answers. So let's use this reference angle of A to find all the quadrant two and quadrant four angles between negative 2 pi and 2 pi. So I don't know why, but I first always do the positive. So I want angles but in quadrant two and four when I'm going in the positive direction. So if I think of the quadrant two angle, that's this one here. What would that be in terms of A?
Pi minus A.
Yeah, exactly. Pi, and then remember, A is the reference. So I'm just subtracting the reference angle. And what about if I were doing, now let's do the quadrant four angle, but the positive quadrant four angle between 0 and 2 pi.
Between 0 and 2 pi?
Yes. So what would this purple angle be? Remember, A is
2
the
pi
reference.
minus A.
Yeah, 2 pi minus A. Exactly. So that's in the positive direction. And then if I think of the negative direction, well, the easiest may be the negative quadrant four. What would that be?
Negative A.
Negative A. Yep. And then if I want to think of the negative quadrant two, how would I represent that?
Negative pi minus A.
Yep, negative pi, and then you also have to subtract a, right? Because this distance would be a, so it'd be negative pi and then go negative a more. And then, so that's the hardest part. And now just divide everything by two. And that's it.
Thank you.
Yep. Okay, Devin.
I had a question on the A2H final review number one.
Yes. What problem on that?
Number nine.
Number 9. And this is not the homework for review one. This was the extra problems, right?
Yeah, the extra ones.
Okay, let me find that. I brought those sheets home so I could reference them. Oh yeah, okay. So this was I'm gonna draw it so people can see. I may have, give me a second. I may actually have it in PDF form that I can pull it off
Okay.
here. So at least it's the one with the graph where you have to graph the two different things.
Yeah, with the absolute values. I was just like a little bit confused because the answer key like was confusing because it had like a bunch of like
Oh
dots.
yeah, yeah, yeah. Yeah, I tried to do it because it wasn't colored. I tried to do it um, so that you could differentiate the two, but I could see how it could be more confusing. Okay, yeah, here it's going to be. Okay, final end of year exam review 3, 4. Of course, I don't see 1. All right, you know what? I'm just going to draw it because it's just a simple sketch. So the original graph looked like this, and then something like that, right?
Yeah. So
Okay.
for the first one where it was like the range is made absolute value, does that just mean that they're like four of like the semicircle things above the x-axis?
Yeah, so whenever you see an absolute value in the y's, which this is, the first thing I do is I literally just trace over anything that's 0 and positive because that's not going to change. And
Okay.
then anything that's negative just comes up
hmm
and becomes its positive. So it looks like that.
hmm And then for the other one, for the one where it's like f of absolute value of x,
Yes.
just mean that the entire left side of the graph would be cut off and you'd only have the right side?
Not quite, but
Uh,
I agree with the left side is cut off. But remember what this means. This means anything on the positive side is not changing at all. So I'm still having all of this.
mm,
But I can equally do the same thing on the negative side, meaning you're mirroring everything on the positive side to be the same on the negative side. So this piece is totally gone, the purple, and instead I'm creating what looks like an even function. So your new graph, when you do the absolute value in X, should be symmetric across the Y-axis.
okay,
And
I
the
see.
reason that makes sense is because, so if I do f of absolute value of 2, that
Mhm.
output is the same as f of 2. So that's why the positive's exactly the same. But now I actually, when I do f of absolute value of -2, that's the same as f of 2,
Okay,
right? Because it's made positive before it even goes through the function. So you can still put in as many negative values for x as you know positive values, because that negative immediately becomes a positive x before it's put through the function,
okay.
which
Thank
is
you.
why those are a little bit more challenging, I would say.
Mhm.
Kai.
Yeah, I was wondering if the final was going to be with calculator, have calculator questions.
No calculator questions. In fact,
All right, thank you.
no calculators allowed. So no calculator questions. I don't even think they're big numbers at all on there, actually. I don't know if that's good or bad. Olivia.
I was wondering how to do review number 2, number 9.
Review number 2, number 9. All right, give me a second. Home review number 2. Number 9. Oh, yeah, this is a little bit of a longer problem, but I think I can do it in a not a long amount of time. So, okay, so this was saying that you've got this. So, for those who don't have it in front of them, the directions are you've got some integer k, and we know k is greater than 2. And this is what else we know. We know log base 10 of k minus 2 factorial plus log base 10 of k minus 1 factorial plus 2 equals, it looks like a weird problem, but log base 10, and we don't even need the base 10 because if it's log, because log without a base, that's implied. Okay, so a few things here. How did you think to start?
I started by, because there's a lot of multiplication, like addition, which transfers to like the multiplication part. Do you get
Yes,
what I mean?
exactly.
I did a lot of
Yes.
that, and then I simplified it all the way down to 0 equal k to the power of 3 minus k to the power of 2 minus 100. And I'm just struggling to solve that right now.
Okay, let's catch everyone up a little bit, and which won't take long, and then we'll get to where you're at. So what Olivia is saying is, which I would agree, whenever you have a problem with, logs kind of all over the place, let's see if we can condense it to a single log on both sides. And one way I can do that is, what can I rewrite 2 as in terms of log base 10?
100.
Yeah. And so now I have all addition on the left. So addition, and I'm going to drop the 10. I'm just going to say log, just so I have to write less. So now I can put this all in multiplication, because addition in separate logs goes to multiplication in a single log, times 100 equals, and what can I do with the 2 on the right side?
You can move it up as like a power.
Yeah, so this is really log k factorial times k factorial, right? Because k factorial squared.
Yeah.
Okay, great. So now that we have that, you set the insides equal to each other. But what I
Wait,
want
is the whole log is the whole log being factorial or just what's inside?
just inside the
Oh,
k factorial.
okay.
Otherwise, there would be parentheses around the log base 10 of k. So the only thing that's the factorial is inside that value of k, or k minus 2, inside the log.
Okay, thank you.
So now I know this is gonna, so actually I'll just write this step just so people don't get confused. So basically now I can set the insides equal to each other. I'm gonna put the 100 in front. Equals k, right? And I know this is gonna simplify, and if I don't quite know how it simplifies, because we did something in one of the counting packets with factorial that was similar, I'm just gonna write out what this means. Like k minus 2 is k minus 2, k minus 3, k minus 4, and so on, right? And then k minus 1 is k minus 1, k minus 2, k minus 3, k minus 4, and so on. And so that's the left side. But then the right side, k factorial is k times k minus 1, k minus 2, k minus 3, so on. And then the same thing over again. Why am I doing this? What is going to cancel, since you have things on the left and the things on the right?
You're going to cancel the k minus 2 factorial, and you're also going to cancel one pair of k minus 1.
So you're going to cancel the k minus 2 factorial, because that's going to go away with all of this, right?
Yeah.
And then all of this will go away with this, but then you're right. One of the k minus 1s will go away.
Yeah.
And so I'm left with 100 only on the left. Right, Olivia?
Yeah.
Equals, and I think this is where you were at, equals
Yeah.
k times k minus 1.
Yeah.
And k squared, sorry. Right? There's 2 k's.
Yeah, it's k squared k minus 1.
Yeah, so this was left over, this was left over, and that k. Okay, so now, to be honest, the next thing I did is I knew k had to be greater than 2. So I just started to, from there, guess and check integers.
Oh,
Because
okay.
this wasn't going to be something that was, because I knew it had, because otherwise you're left with, I guess, you could do, but this isn't how I did it. I knew it wasn't going to be that big, so I knew I wasn't guessing and checking for a long time. But the other way to do this, which just seemed, So k cubed minus k squared. What am I doing? Sorry, equals 100. And if I brought the other way to do this would be, which seemed so exhausting, finding all values p over q and doing finding a zero that works and synthetically dividing so I could factor and find the rational zeros. No need to do that here. In this case, I just started trial and error. I first did we know greater than 2, so I tried 3, and 3 would be 9 times 2. That doesn't work, right? Then I tried 4, 16 times 15. Why am I doing 16 times 15? Guys, my brain is shot. 16 times 5. Not 5, 16 times. Feel free to chime in. Times 3, 48. And then I did 5, which is 25 times 4.
4.
Yay! And so that worked. So I said, okay, so k then is 5.
Oh, I see. See,
So-
that's where, yeah,
Oh, sorry. Go ahead, Livia.
that's where I like got really stuck.
Yeah. And you know what? This is like a fun problem to practice factorial, to practice rule of logs. Is this a great test problem? No, because everyone would get stuck. But this was a great problem just to practice and figure out, okay, what could I do here instead of like doing P over Q and trying to factor this thing?
Could you have done U substitution after that step, or
I mean, what would you have U be?
like U equals K squared?
So then you'd have, if U is K squared, then you'd have, So what
Because it would be K to the power K cubed minus K squared equals 100. And then
yeah.
you've basically gone U squared minus U minus 100 is equal to 0.
Wait, what do you, but it's K to the third. So if U is K squared, how are you placing?
Oh wait, never mind. Yeah, my
That's the
bad.
bummer of this. There's not like,
Yeah.
I too thought, oh, what about if I can do a U? But the U does not work out nicely here.
Okay,
Basically starting back at square zero,
okay.
square one, square zero. Oh my God. Sorry, everybody. Square one. Literally just got back from Menlo like 20 minutes ago because I was giving placement tests to freshmen until 7 something. Whew. Okay, Alan, go for it.
I had a question for the first review packet. I think it was number 8.
First, so tell me, is this final exam one, the extra or the homework ones?
The extra one.
Okay, number 8. Yes, sir. All right. Number 8 in general or a particular one of number 8?
Like in general, because I don't really like understand like the odd even stuff. Because like I think I also missed that.
Okay. So basically I'm giving you that f of x, x of x is odd and g of x is even. So whenever I give that piece of information, right away, my recommendation would be, this means that f of negative x is negative f of x. That's what odd means. Even means g of negative x equals g of x. So I'm going to write that down to begin with. Once I know what's odd, what's even. And then, so then I'm asking you a bunch of compositions or function operations. Are these results even or odd? So for example, part A, I'm asking you to analyze what f of g of x is. And always the algebraic test for even or odd, and that's the only choice you have here. You can't graph because I don't even give you what these functions are. The algebraic test is plug in negative x. So when I plug in negative x, I'm plugging it into that inner function. And I know g of negative x, because it's even, is just the same as g of x. And because when I plugged in negative x, I get back exactly what the initial function was. What type of function is this?
Even.
Even, yeah. And I
Oh.
do the same thing. Let's do another that's a little bit different. Let's do, actually, we'll do the second one and then I'll do one more. So g of, again, the test is plug in negative x. And I know f of negative x equals what?
F of negative f of x.
Right. And so now I'm doing g of negative something. But because g is even, g of negative something is just the same as g of f of x. Therefore, we're still back to what we started with. So it's still even.
Wait, but I thought the negative had to be inside for the even to be.
But so we're rewriting it is, so think of it, we're doing now the outer, we're rewriting g, we already did f of negative x, and f of negative x is negative f of x. So now when I think about what g of negative a function is, remember this is the inside of the g function right now, right? Because it's a composition. So if I'm doing g of negative something, this is just the same as g of the positive counterpart of it.
So it's even.
Yes.
Okay.
And let's do, say I had something like part D, which is f of x plus g of x. So
Mm-hmm.
to test if it's odd or even or neither, I plug in negative x. Wherever there's an x, you plug in negative x. And f of negative x, since it's odd, is negative f of x. What about g of x, though?
That's just g of x.
Yes. And so this is the case where it's certainly not the same as the original, and it's not odd either, because to be odd, everything has to change sign, and only f of x changed. So this is the case where it'd be neither.
Oh. But if f of x was positive, you said be odd.
No. If f of x, if they both stayed, if it
Uh.
ended up at f of x plus g of x, then it's the same thing as the original, so it'd be even. However, if it had ended up like negative f of x minus g of x, what would that have been?
Odd, because
Odd.
it's all negative. Okay, I see.
Yeah, if everything changes, then it's odd.
So, and if nothing changes, it's even.
Yes.
Okay.
And if only part changes or nothing, neither.
Okay.
All
Thank
or
you.
nothing.
Miss Jensen, can you go over B again? I didn't fully understand why it's even.
Yes. So so let's go back to it was g of f of x, right? And so keep in mind the domain of the outer or the input of the outer function is f of x. But first to do this problem, we're just first putting in negative x for x. So we're first dealing with f of negative x. And because f is odd, what, Sabina, is f of negative x equal to?
Negative f of x.
Yes. So now think about when we would have like cosine of negative something inside, like cosine of negative, I don't know, say it was negative pi over 2x. That would be the same as cosine the positive, right? Because cosine's even. The same is true here. I have g of negative some input, because f of x is the input of the g function now. So g of negative some input, because g is even, is just the same as g of f of x.
So when looking at the even and odd functions, we're mainly looking at what you put inside of it. Is that right?
So you're working with a composition, you have to look all the way from the inside out. So first thing I did with the composition is I worked with the inner function. So when I realized that f of negative x can be written as negative f of x. Now that I've taken care of the inner function, now I'm working with the outer function. And the input of the outer function is this inner function. So if I'm doing g of negative some input, then because g is even, that's just going to be g of something out of the same thing, f of x. Think of it this way. Say it was g of, because first do you agree with the composition? First, you're putting the number through the inner function. And then you're going to get some value. So say you knew that 2 went to 4 and negative 2 went to, where do I want negative 2 to go? Negative 2 went to 6 or something. And then 6 went, I'm trying to make it so this works out. 6, negative 2, it, no, that's going to confuse things. I'm actually not going to do it that way. That's going to confuse you. All right, so let me take it a step back. So say you put in some negative number, and because it's odd, it's going to be the negative the output. So say the output was originally 5. When I goes through, if f is odd, then the output is going to be negative 5. Now I'm doing g of negative 5, but because g is even, g of negative 5 will just be the same as what?
G of 5?
Right. So that's the idea here, because you're thinking that this function here is just going to output a number. So I'm really talking about g of negative some number. And because g is even, it's going to be the same as g of the positive version of that.
Okay, I think that makes sense. So just go from the inside out.
Inside out, always with compositions, inside out.
Okay.
Nilesh.
Yeah, I had 2 questions on the final exam review too. The first one was on number 2.
Yeah.
I wanted to know why you approached it with like a systems of equations in the answer key, because I thought when we have like imaginary solutions in the graph, we draw like that little line.
Right.
Find the x-intercepts, but like you used systems of equations, so I got a bit confused on
Yes,
to do
the
there.
only thing, and I actually think I can pull this one up so people, because this requires a visual. So when we did in class what you're talking about, when I drew the line, that was just to figure out what the degree was and how many real and how many imaginary roots there were, but we never used it to actually find specifically what they were. In fact, we can't. So we have to do something like I did here. Let's see, exam review. Oh my gosh, where is this exam review? All right, give me a second. And exam review. Homework for some reason I can find all the homework ones, but I can find only exam review 3 and 4. All right, I don't want to, since time's limited, I'm just gonna, so this is what we have. If you guys have it in front of you, great. But if not, I want to show you to give you an idea of what Nilesh is talking about. So this is basically what we have for the graph. And some points is 0, -6. And this point is -1, 0. And I also gave you the point -2, 3. So -2, 3. And the last point I give you is -3, 3, I believe. Yeah, so the question in this problem was find f of x, find all the roots, real or complex. So the only real 0 I have is -1. And Nilesh, what you were talking about is the great way to figure out what degree this is. And what degree is this polynomial? Like if I redraw my axes, it would be degree 3, right? Because if I draw it here, it's like curving through. So I mean, this drawing I did isn't the best, I'll be honest, but yeah, so it's degree 3. So I know if I have a real solution, I know that from that is x plus 1. And then that means what should I have left over?
A quadratic, right?
A quadratic. So then I just did the general form of the quadratic. And then, as you mentioned, I used my 3 points. I'm not going to use -1, 0, because that would result in me multiplying by 0 and not solving for anything. I'm going to use the 3 other points to set up a systems of equations to find A, B, and C. And so that's part A. So once you do that, then you can, the other part of the question is find all roots, real or complex. We already know the real roots, -1. And then you would just solve this using the quadratic formula to find the complex roots. That's the only way to do this, Nilesh. There's no way. The thing we did in class was just figuring out what degree the polynomial was and the number of real and complex. So it actually just ended up being
Okay, that makes more sense.
a fun systems of equations problems. If I'd given you this on the test, what I would have set up would be I would set you up with this, and I would say now use a systems of equations. So I'd make it more a systems of equations problem, and telling me the complex roots. So using the quadratic formula and your knowledge of I to get those.
Okay, cool. And then on the same review packet, could you go over 8?
See what 8 is?
It was
Oh yeah.
right before the factorial one.
Yes. Okay. So this was suppose you have
Thank you.
an ordered pair. Sorry, I'm gonna copy this down so people can see it. So log base 10. I'm not gonna bite the base 10. It'll be implied here, and log x over y equals 1/2. So the question is, if y is increased by 50%, what fraction must x be multiplied to keep this equation true? Any ideas? I mean, what I thought of doing is, looking at this equation right now, I'm like, this equation with logs, me comparing what x is versus y is going to be pretty hard. So I was like, let me simplify this equation first and tell me if you can follow what I'm about to do. What did I just do on the left?
Change of base.
Change of base. Yes, great. Change of base. That's important to know to be able to do the change of base in any particular problem. Like if I have a log of the same base top and bottom, but I want a singular log, because there's no division in separate logs rule, I can use the change of base to make it so a single log. And now, again, I don't want to deal with logs, especially if I'm talking about increasing something by 50%. So I'm going to say xy to the 1/2 x over y, sorry, equals xy.
Wait, could you also get that just by multiplying across and then putting the 1/2 in the numerator?
Yeah, totally. Yes. So you totally, great. Yes. So you could have gotten this by multiplying across and the half comes up, right? And then I don't want to, and then the insides would be equal. Yes. And then I didn't want to deal with to the half, so I squared both sides. So if I square both sides, what do we get then?
X squared y squared equals x over y.
X squared y, oh, sorry.
Oh, yeah.
I was doing the other side, sorry. X over y equals x squared y squared. Yep. All right, so remember, we're talking about the relationship between x and y, and I'm going to read it in case you don't have it in front of me, the direction again. It's saying if y is increased by 50%, by what fraction must x be multiplied so to keep this equation true? So first, let's now figure out what is x equal in terms of y. So
1 over y cubed.
So right now I'd have, actually, I'm going to yes, you're right. I'm going to do this a little bit differently. First, I'm going to simplify this x, because if I divide both sides by x, I get x on the right. And then if I divide both sides by y squared, I get 1 over y cubed, like you just said. Okay, so now if I increase y by 50%, instead of y being 1, what is y?
1.5.
1.5. Although I hate decimals, so I'm going to instead say 3 halves. So 3 halves cubed equals x. Or what is it? Oh my gosh, my handwriting. Or I could say 1 over 27.
Oh.
And so what is x must be, what does x have to be multiplied by in order for this to, the relationship to be remain the same?
8 over 27.
8 over 27, right.
Why does saying increase by 50% meaning you can get rid of the y? How come it's not 3 halves y?
Oh, sorry, there should be y. My bad, sorry. It should be y. I didn't get rid of the y. My bad, sorry.
Okay, got it.
Sorry, I should have got
Okay.
rid of the y. Thank you for pointing that out. Y didn't just disappear. My bad, so sorry. Yeah. Yeah, otherwise this isn't making sense. Where the heck is y gone? Yes. You're right. I shouldn't have gotten rid of the y. Yeah, so to make it so that it's still 1 over y cubed equals x, x would have to be 8 multiplied by 8/27, because then you end up with still x equals 1 over y cubed.
Thank you.
Yes, you're welcome. Jacob, go for it.
Wait, okay. So I had 2 questions, but now I have 3. Can you show us like mathematically how that would work? Changing x and multiplying that by 8. Because wouldn't you get 8 over 27 y squared, right? Y cubed.
So if I multiplied, so if I take this here and multiply x by 8/27, right?
Yeah.
Okay, so then what would happen here? Because if I solve for x again, to isolate x to see what x's relationship is to y, I divide both sides by 8/27, right?
Yeah.
Wait, so if I have, this is the fraction on the left, and dividing by 8/27 is, so if I divide this, it'd be the same as multiplying by 1 over 8/27. Right?
Oh, I see how it cancels
Because
out.
when you divide fraction, I know it can be confusing to think about, because you have like basically, we're dealing with like a fraction within a fraction. So that's why it can be confusing. So that's why I have to remind myself when I divide, I'm really multiplying by the reciprocal. So I was just doing 1 over 8/27, just so everything could be in the bottom on the left.
I see. Could we also go over number 5B on the trig test?
5B on the trig test, sure. Let me see what was 5B, if you can. I'm gonna get it, but remind me what 5B is.
5B is like that inverse sine function that's like it asks for the range, but like it said I got it wrong.
Okay,
So
so tell me give me the function. I thought I had that test with me, but I might.
2 sine to the -1. Inside the inverse sine is 3x minus 5, and then the
Yep.
whole function plus 1.
Okay, and you want the range, domain, the whole bit, or what?
Just range.
Okay, so what comes out of inverse sine?
0 to pi.
That's your issue. That's inverse cosine. Inverse sine is -pi/2 to pi/2.
Dude, oh my God, that's my problem. That's my problem, man. Okay. Okay, yeah, I think I can solve it then.
Yeah, so it's -pi plus 1, pi plus 1. Yeah, so write those on your note card so you can always double check.
Okay. Okay, one more thing. Can we go over all the ways to write a quadratic? Like all the forms real quickly?
Yeah, so that'll be quick. Yes, so standard form, ax squared plus bx plus c, right? That's standard. Then completed square / vertex form is this. So vertex form. And the root form, that's the easy way to get the x-intercepts, otherwise known as factored form, is that.
Wasn't there like a third form where it's like x plus 1 on the other side and then a y minus something on the other side?
That's point slope.
Yeah, are you talking about lines?
No. Oh, maybe I am talking. Oh, never mind. That's lines. What's the vertex for each one of these?
So negative b over 2a, f of negative b over 2a. Then this one's easiest for the vertex, hk. And this one would be x1 plus, not x1, sorry, r1 plus r2 over 2, and then just plug that back into the function.
Okay, thank you.
Yes. Let Jackson.
Okay, so I only have one, actually I have two questions, but the first one is for the Unit 3 test, question number 5. I don't know if you can pull it up. If not, I can like just say it.
Yeah, to say it to remind me, and then I'll see if I can pull it up probably on my computer to see. Yeah, if you tell me what it is, then I might be able to do it without pulling it up.
It says find all the values of m for which the roots of 2x squared minus mx minus 8 equals 0 and differ by m minus 1.
Oh yeah, I was just doing this with someone. So, okay, so say it to me again.
Okay, sorry. 2x squared minus mx minus 8 equals 0.
Yep.
And the roots differ by m minus 1.
And what was before you gave me that quadratic? What was the words before you said the quadratic?
Let me see. I stapled it kind of weird. Find all the values of m for which the roots of, and then that.
Okay, so there's no m anywhere except differ by m minus 1.
Oh no, it's negative mx though.
Oh, there's an m here.
Yeah.
Oh, okay. Now this is making more sense. Okay, so minus mx. That is how it's written?
Yes.
Okay. Okay, so if roots differ, it means when I find the roots, r1 minus r2 is m minus 1, right?
Yeah, wait, what's r, sorry?
R stands for the roots.
Oh, okay,
So
yeah.
once I find those x-intercepts, they're going to differ by m minus 1, meaning when I subtract them, I'll get some m minus 1. So I need to find the roots. If m is in there, I'm not going to be factoring it. So I'm going to have to use what to find the roots?
Oh, the quadratic formula.
Yeah. So to find what x is, or the roots, I should say r1, r2, not x. R1, the roots are negative b, so m plus or minus b squared. So m squared minus 4ac over 2a, so over 4. So in other words, this is m plus or minus 64, m squared plus 64 over 4. Is that okay?
Yes.
So now let's set it up. So the two roots are, you've got one of them, m plus m squared plus 64 over 4 minus m minus over 4 equals m minus 1. So now they have a common denominator, which is 4. And if I'm putting it over that common denominator, what's the left side going to simplify to? Because something's going to cancel. Actually, let's just multiply both by 4. What am I doing? Let's multiply both by 4. So 4m minus 4 equals, distribute the negative through here, right? To here and here. So what am I going to be left with on the left side?
2m squared plus 64.
Yeah. I would divide everything by 2. So square root of m squared plus 64 equals 2m minus 2. Now what?
You square the left side and the right side.
Yep, so m squared plus 64 equals 4m squared minus 8m plus 4. And then what you're going to end up doing is well, what do you think you have to do now?
Either factor, use the quadratic formula.
Yeah, I'm pretty sure I'm almost positive it was a factoring because did I even say that m is an integer or no?
You didn't specify, no.
Okay. Let me see if I can quickly figure out this factoring. 3, 1, 15, 4, 12 and 23. What else? 6, 10, 18, 10. Oh yeah. Okay, so 6 and 10 will work. So 6, 10. So that seems to work, right?
Yeah, that looks right.
So m is 6 or m is negative 10/3. And so the only thing that you want to check is why do you think we have to check? Why can't I just give those as my answers?
Oh, leave extraneous because we squared it.
Yeah, I might have extraneous. So what you want to do, I mean, the best way to check is to first find plug back in these for m to find the roots. Remember, these are the roots. And so you could see what the roots actually are and see if, in fact, if they do differ by m minus 1 in both cases. I don't remember taking off if people, or maybe I took off minorly if people didn't check. The other way you could check is just to make sure that you could check here before you squared both sides to make sure this was true as well.
Okay.
But that was the process. That was a long problem.
Wait, Miss Jensen?
Yeah.
Can't root 2 minus root 1 also be m minus 1 though?
Root 2 minus root 1. Where are you getting root 2 and root 1?
Because you have like m plus root m squared plus 64 and then m minus root m squared plus 64. Couldn't you have the negative one first?
Yes, you could have the negative one first. That's why I think it's best to plug them both in to find the roots and then see if both of them actually work. Because when you do the difference, you can do the difference using both ways, right? Subtracting the first from the second or the second from the first.
Well, will that mean they have the same roots?
Either way. You would still get the same, right? Yeah, you would still get a version of like 6 and negative 10/3 if you did it the other way too. Because really the only difference is you're going to have, like if I think of m, so then instead of this right here, the only difference is you'd have negative 2.
Yeah.
And then, so then when you square both sides, you're going to get the exact same thing.
Oh, okay.
So you're not going to get, you're not really going to end up getting anything different because, again, you're squaring both sides. But because you are doing that, you want to check back in the original.
Okay, yeah.
Wait, Miss Jensen, I think I remember this problem. Could we try doing it dividing it by -2 instead of 2? Because I might be remembering this wrong, but I feel like you get different answers.
So if you divide it by -2, you mean if you have m squared plus 64 and you get negative 2m plus 2, right?
Yeah.
Yeah, so now if you square both sides, m squared plus 64 equals what you get 4m squared minus 8m plus 4 still.
Oh, I see.
So the reason I think what you're thinking of is
Oh,
if
but you still need both. You still need both because one of them will only work in the one where it's -2, but the other one will only work in the one where it's +2.
yeah, so that's what I mean by if you instead of checking right before you square, because you're right, depending on which you're doing, the negative or the positive, one will work or the other. I would instead check in the original and see, does this make the statement true? Like if I put in 6 for m and find both roots, do they differ by 6 minus 1? Same with -10 thirds. If I put it in for m and find the roots, do they indeed differ by -10 thirds minus 1?
Oh, I see. Okay.
Okay, Ms. Jensen, and then so for my second question, I was looking at the quadratic quiz, number 6, which is like the one with the track, and
Yes.
just can't really figure out like what I did, or, like how I did it at all.
Why don't someone else asked me, because that's going to take a long time. I can send you my solutions to that. How about that?
Oh yeah, could you do that, please?
Yes. So
All
I
right,
can,
thank you so much.
Could I also get it?
yeah, I'll just
Yeah,
send
that
it
was
to everyone. I'll just send it to the whole group. So you have
great.
it.
Okay, thank you very much.
Yeah, because I think that's easier. And I also am happy tomorrow if you come to tutorial to explain it too. Um, but I think that's probably easiest. Liam, I haven't heard from you yet. Yes.
Could you go over like the equations for permutations and combinations?
The like what they equal in terms of factorial and stuff.
Yeah, the ones with like n factorial and k factorial.
Yeah, the good news is
Yeah.
you're not going to have to know that, but I'm
Okay.
happy to show you them because I'm going to allow you to leave it in permutation notation. Like if it's, you can leave it as 10p3, for example. But just so you know, it would be n factorial over n, I think I used k. I can't remember if I used k or r, over n minus k factorial.
Okay.
And if it's a combination, which you can do like this, or you can do NCK or CNK. Oops, not that. It is equal to permutation, actually, except you also have to divide out order.
Okay. So for the final, should we just know like how to basically just use choose notation?
Yeah, just use choose or just write it out like
Yeah.
10 times 9 times 8.
Okay.
Yeah, I'm not going to make you manipulate the formula or anything like that.
Okay.
All right, Yuna.
Hi, I had a question on like the final review too. It's a pretty short question, but question number 3.
Question number 3. Yeah, I actually have this in front of me. Oh, that's one in my email I said we haven't done this year.
Oh, okay. So like the arithmetic progression is like something we don't have to worry
You
about.
don't know. You're going to do it over the summer and at the beginning of next year.
Okay, fantastic.
Yeah, so that's one. There were a few problems here or a part of a problem, not many in these reviews that we just didn't cover. So that's out. And you don't have to worry about that. Okay, Ishu.
Hi. I had a question about 2.7. It's like the unit 2 wrap up.
Yeah.
There was a problem, number 7, I believe. It said like devise a system of linear equations that would have the solution 3k minus 4 k and 5k plus 1.
Yep.
And I was just wondering kind of like the process to like doing that because I kind of forgot how to.
Yeah, you always start, and there's probably, as I was telling people, I think in C block today, there's like as many kids as there are taking the test would probably giving that many answers. There's infinite answers to this, but you always want to start with the things that aren't just K. So in this case, my X and my Z aren't just K. I'm going to leave my thing that's just K till last. It's just easiest. And then you randomly pick any coefficient of X in this case and any coefficient of Z. So for me, it's easier just to do coefficients of 1, make my life easy. And then what I'm going to do is based on that, I'm going to find what the coefficient of y needs to be and what the constant term needs to be. And what I mean by that is plug in what x is in terms of k, plug in what z is in terms of k, and notice I have 8k minus 3. So in order for this to be a solution, and this equation ends up being true, I need the k's to cancel. So what does the coefficient of y have to be so that my k's go away?
8.
-8, right?
Oh yeah. Well, yeah, if you're doing minus. Oh yeah, sorry, I thought that was minus y.
Would
So
be
yeah.
minus 8k, great. And then what would the constant term on the right have to be?
-3.
Yes. So that's it. And then the next one I might be, oh, let's do -x and positive z and do the same process.
Okay.
And you just need 3 of them. And the way I check people's solutions is I literally just plug in these coordinates in terms of k and make sure I get a true statement.
Okay. Sounds good. Thank you.
Yeah, Devin.
I was really confused on like one of the imaginary problems on review packet 1, like the extra one.
Okay.
Want me to just tell you the question?
Yes, I have it. You can tell me what number it is.
It's number 29.
29. And